My name is John Graville, and I'm a professor in the agronomy department at Purdue University. And what we're going to do today is talk about soil profiles or soil monoliths. Here in the agronomy department, we have over 400 soil monoliths that we use in teaching a wide variety of different soil science classes. So, as you're driving down the road, one thing you notice about soils is you notice that most of them look fairly dark on top. We call that horizontal variability. But what's really interesting and cool about soils is once you dig into the soils and you start to look at the vertical variability, that's when soils, in my mind, really come to life. So, for example, on this monolith right here, it looks sort of dark on top, but when we dig down into it, we find a soil horizon that looks something like this, very light in appearance, all right? And then we get a darker color area here, and then we get a redder color area here. So we call that vertical variability. So what you notice about soils by just looking at them is the wide variety of different colors that we have. We have grays and browns, we have tans and reds, we have white colors, we have black colors. So we have this wide range of different colors. And we can use colors to actually help us define soil horizons. And so what I'm going to do over the next couple of minutes is define for you the 6 master horizons that we can find in the soil. So I'm going to start off talking about the topsoil. The topsoil is the A horizon. And the A horizon is at the very top, all right? It's usually dominated by organic matter, as you can see in these profiles. So organic matter in parts of very dark color, either black or dark brown, that is typical of an A horizon. A B horizon is called the subsoil. And the subsoil is where everything has accumulated. So as soils weather, what happens is that things sort of move out of the A horizon and they accumulate down in the B horizon. So over here we have nice B horizons, and essentially the B horizon, it has a higher clay content. So for example, it would be like a silty clay loam texture in the B horizon compared to the top horizon, which would be probably a silt loam. So the B horizon is the horizon of accumulation. It is also the horizon which is most colorful in a soil, is the B horizon. The C horizon is the parent material, and that's the material from which the soil formed. So at the bottom of this profile here, and that profile, and the profile on the far left-hand side, those soils over there, all right, which you're actually looking at, is called the parent material. And again, that's the material from which the soil was formed. So those are 3 of the master horizons. We have 3 others that we use. One of them is called the O. And the O horizon stands for organic. Usually the O horizon is just used typically with organic soils or in virgin forested sites, sites that have not been clear cut for many years. So essentially that's possibly where we could use the O horizon. So this would be an O horizon, an organic horizon. The other master horizon that we have is called the E horizon. The E horizon is a bleached horizon. And what that means is that everything's been leached out of it, all the clay and the iron and so forth. And so what's left behind is a very white sort of appearance to that soil horizon. That's called the E horizon. At the bottom of this particular profile here, we have a lot of rocks. And that's the R horizon, or the regolith. So we have essentially the A horizon at the very top. We have the B horizon, and we have the C horizon and the R horizon, and then in some soil profiles we have unique features like the O and the E horizon.